Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about some applications involving right triangles. So the first problem that we are going to look at is solving a right triangle. So solving a triangle means we have to find all three sides and all three angles. Okay, so let's go ahead and draw this triangle first. So it's a right triangle. So let's draw the right triangle. Okay, so this is 90 degree. So let's name it A, B, and C. We are given angle B is 40 degrees and side B is 10 centimeters. And then let's say this is side A and this is side C. Now let's go ahead and find side C. So in order to find side C, we have to use one of this angle and this side here. So if we take angle 40 degrees, that means, okay, before finding that, let's go ahead and find angle A because that's the easiest one. So we know this is 40 degree, this is 90 degree. So angle A must be, so A must be 90 minus 40 degrees because the sum of B and A must be 90 since the sum of the angles in a triangle is 180 degrees. So this is 50 degrees. So we got angle A equals 50 degrees. And we are given angle B equals 40 degrees. And we know that angle C is 90 degrees. So we have all three angles. Now we need to find sides. So let's go ahead and find C. In order to find side C, let's use this angle B and this side here. So if we are using using angle B, then this is the opposite side and this is the hypotenuse. So we have to use sine of 40 degrees equals opposite, which is 10, divided by hypotenuse, which is C. Now if we do the cross multiplication, we get C times sine 40 degrees equals 10, and then if we divide by sine 40 degrees, we get C equals 10 over sine 40 degrees. And then if we put this into the calculator, we get approximately C equals 15.56 centimeters. So now let's go ahead and find A. So in order to find A, we can use angle A if we want, but we can still use angle B. So if you use angle B and if we want to use A, if we want to find A, then using opposite and adjacent, which means we have to use tangent. So tangent 40 degrees equals opposite is 10 divided by A, which is the adjacent. Now, if we do the cross multiplication and then divide by 10, 40 degrees, so we get A equals 10 divided by tangent of 40 degrees. And then approximately that equals, if we put this into the calculator, we get 11.92 centimeters. So now we have A equals 11.92 centimeters. B was given 10 centimeters. And then side C, we obtain that is approximately 15.56 centimeters. So we have all three angles and all three sides. So that means we solve this triangle. Now, in trigonometry, when we are dealing with some applications, we come up with these two terms here. Okay, so one is angle of elevation and angle of depression. So let's draw a figure here, and then I'll explain that. So, for example, we have an observer here. Someone is looking at something. Okay, so if someone is looking above the horizontal line, let's say right here, here's an object. Someone is looking over there. Now let's say this is the horizontal. Okay, now this angle made with the horizontal by this direction of this side. Okay, so this angle is called the angle of elevation. Now let's say from the same point someone is looking down. Okay, for example, you are standing on a height and you are looking down. So if someone is looking down and then object is somewhere here, let's say right here is an object, and someone is observing that object from here, okay? Now this angle that is again made with the horizontal, okay? In both cases, the angle is made with the horizontal. This angle is called the angle of depression. Okay, so this is these two terms are very important. Okay, so angle of elevation and angle of depression. Now there's another term which is called bearings. So in trigonometry, we use this. This has a use application. We use this in navigation, like pilots and the ship crew. They use this bearings concept. Okay, in order to know the direction, or to find, to navigate their path. Okay, so there are two ways we use these bearings. Okay, so the first one, let's talk about the first one. So I'll call it method one or type one, whatever you call it. Okay, first one, when we talk about bearings, it gives the direction where something is. Okay, the location of something. So you are staying here, and in which direction some other things is. So that direction, the first way we just we'll just have an angle. So for example, if someone says something is at a bearing of 30 degrees, okay, so if we are just given that angle, just one angle is in the direction of 30 degrees, a bearing of 30 degrees, then what we have to understand is always in that case, we start with the north direction. Okay, so we have this north. So from north, we go in clockwise direction. So from north, we go 30 degrees, and then that object or that thing is in that direction. So from north, 30-degree in clockwise direction. So that's one method of using bearings. Okay. The second method is a little bit different. So another method of using bearing is will be given the direction, not just the angle. So for example, it might be written north 30-degree east. That means we start with this direction and then we go towards this direction at an angle of 30 degrees. Okay, so for example, this one, if I have to draw that, so it is from the north, okay, and from the north we go to the east. So in paper, north is top, south is bottom, east is right, and west is left. Okay, so we go to the east 30 degrees. So that's how we denote that. So for example, if the same thing, if I write north, and not the same thing, if I write north 30 degrees west, the bearing or the direction for that one is, so again we start with north. Okay, so this is north, and then we go 30 degrees to the west from north. So we go 30 degrees to the west, and then that thing is in that direction. So that's what this means. Now we could have south 30-degree east. If we have that, then in this case we don't start with north, we start with south. Okay, and from the south we go 30-degree towards east, and it is in that direction. Now if I write south 30-degree west, so again start from the south, okay, and then I go to the west 30 degrees. So this is the direction. So this one helps the in navigation, like GPS and all of that, because that angle will help us in which direction we are going, or in which direction something is in. Okay, so to locate things, this is used. So let's look at some applications examples. So here, a 20 feet ladder leans against a wall. So let's draw the wall. It's the wall. And then we have the ladder. So let's say this is the ladder leaning against the wall. Let's say this is the ground. Sorry. So that is the ladder, which is 20 feet, the length of the ladder. And the angle between the ground and the ladder is 55 degrees. So this angle is 55 degrees. Now it says, how high does the ladder reach? So we are asked to find the height, this height of the ladder. So let's say that height is x. Now we are given hypotenuse, we want to find the opposite, and we are given, so this is the reference angle, that means this is opposite and this is hypotenuse, this is 90 degree here. So we can use sine function here, okay? So if we do sine of 55 degrees equals opposite over hypotenuse. Now if we multiply by 20 on both sides, so we get x equals 20 times sine 55 degrees. And then if we put this in the calculator, we'll get approximately 16.38 feet. So that is the height that the ladder can reach based on that information. Let's look at another example. A tower is located 200 feet from a building. So let's draw a tower. So let's say that is the tower. And let's say this is the building. Now, the distance between the tower and the building is 200 feet. From the roof of the building, so from here, a person determines that the angle of elevation to the top of the tower. So this is the top of the tower. So from here, that person looks up. Now we need to draw the horizontal. So this is the angle of elevation, which is 40 degrees. Okay. Now we know that this is 200 feet. That means this must be same. So this is also 200 feet. Now, and that the angle of depression to the bottom of the tower is 35 degrees. So from here, he looks down to the bottom of the tower. So from here, he looks down to the bottom. And then that angle of depression, this angle is 35 degrees. Okay. Now, how tall is the tower? So we need to find the height of the tower. So what I'm going to do here is I'm going to say, so we have two triangles, two right triangles here. So I'm going to use this top right triangle. This is right angle here, and find this height from here to here. Let's say that is x. Okay. And then I'm going to use this another right triangle right here, this right triangle, and I'm going to find this height from the ground to this height, okay? And then if I add x and y, then I get the total height of the tower. So let's use the top triangle. So from the top triangle, if you are finding x, we are given this one, so opposite and adjacent, that means we have to use tangent 40 degrees equals x over 200 feet, okay, x over 200. Now if we multiply by 200 on both sides, we get x equals 200 times tangent 40 degrees. Let's not put this into the calculator now, we'll put everything together at the end. So now let's use the bottom triangle, okay? So using the bottom triangle, again, this is opposite, this is adjacent, so we can use the tangent 40 degrees equals, again, opposite over adjacent. Okay, or if we multiply by 200, we get y equals 200 tangent 40 degrees. Now the height of the tower is given by x plus y, this height plus that height. So now x plus y is, x is 200 tangent of 40 degrees plus y is 200. Sorry, I made a mistake here. The angle of depression is not 40 degrees, so it should be 30 degrees. So this one, it is tangent of 35 degrees equals y over 200. And that gives us y equals 200 tangent of 35 degrees. Sorry, when we use the lower triangle, this angle of reference is 35 degrees, okay? So 200 tangent of 40 degrees times plus 200 tangent of 35 degrees. And then if we put this into the calculator, we'll approximately get 307.86 feet. And that is the height of the approximate height of the tower. Now let's look at one more example. A ship travels 65 kilometers on a bearing of 50 degrees. So we are not given any south or east or west or anything. We are just given an angle. So if you are just given an angle, we always start with the north direction. So let's draw that. So this is the north direction. 50 degrees, that means from north we go 50 degrees, okay, clockwise. So let's say right here. So it goes 65 kilometers on a bearing of 50 degrees. So this 65 kilometers, and then suppose it reaches here, then travels on a bearing of 140 degrees. So from that point, again, we have to draw the north. And then from here, it goes in a bearing of 140 degrees. So maybe in this direction. So this is 140 degrees. Now we're asked to find, so and it goes 75 kilometers. So let's say it reaches this point. Now find the distance traveled from the starting point to the ending point. So we need to find the distance from here to here. Okay, so distance from here to here. So let's connect those two dots. So we are finding this distance, and let's say that is x. Now we have this side, we have this side. We don't know if that is a right triangle or not. So if it is a right triangle, then it's easy to solve this one. So let's go ahead and check if it is a right triangle. We know this angle is 50 degrees. Now these are parallel lines, both are pointing to the north. So that means we can use the concept of the interior angles in a parallel line. Okay, so the sum of this 50 degrees and this angle must be 180, or the measure of this angle right here, the measure of this angle is 180 minus 50 degrees, and that is 130 degrees. So this is 130 degrees. Now we know that the total angle in a circle is 360 degrees. This is 140, this is 130. So we can find this inside angle. So we can do 360 minus 130 plus 140. And if you put this into the calculator, we get 90 degrees. That means this angle right here, this angle is 90 degree right here. Okay, so this is 90 degrees. Now it makes our work so much easier. If that is 90 degrees, then this x is the hypotenuse, so we can use Pythagorean theorem. So x equals the square root of 65 squared plus 75 squared. And then if we put this into the calculator, we get approximately 99.25 kilometers. We'll just do this much for this video. I'll see you again in the next video.